guys, welcome back. This is Sakshi Kakade, and in today's session, we are going to see how we can implement one stack by using two queues. So let's move towards the point. So in this program, whenever we are going to implement the queue, we are going to use the linked list for this concept. So let us consider that these are my two queues. The first one is the first queue and the second is second queue. So by performing some of the operation on this both queues, we have to make, or we can say that we have to give the output as like a stack. So by using only these two queues, we have to give the output as like a stack gives. That is, we will get the one stack by using two queues. So we all know that the queues work on the principle of first in first out, that is the FIFO principle. That is, the element which we have enqueued first will come outside first, whereas stack works on the principle of LIFO, that is last in first out. So the element which we have entered last or which we have pushed last will become out first from the stack. So by using these two queues, we have to make one stack. So in this program today, we are going to see how we can implement two queues and make one stack. So let's move ahead towards the point. So again, let us consider that these are my two queues. So the first one is Q1 and the second one is Q2. Let us consider that these elements are present in my first queues, that is 25, 17, 8, 90 and 44. So what we have to do over here is that we have to perform the DQ operation on the Q1. That is, we have to take out elements from the Q1 and we have to perform the NQ operation on Q2. That is, we all know that Q works on the principle of first in first out. So in this case, as 25 is the first element, so firstly it will be get enqueued into the, it will be get dequeued from Q1 and it will be get enqueued in the Q2. Again the next element is 17, so it will get dequeued from the first queue and again it will get enqueued in the second queue. So this process goes on until we get a last element into the first queue. That is, we have to pop the last element which is then present into the queue first. So the first element which we have pushed was 25 and the last element which we have pushed was 44, and we are going to take out the element 44. That is, in this case, you can see the first element pushed was 25 and the last element pushed was 44. So according to stack, the output or the pop operation, in the pop operation we should get the element which we have inputted last. So in this case we have inputted 44 at the last position, so we will get the element 44 in this output. So this is the basic logic for the program, how we are going to implement the stack by using two queues. So this is the way how we will perform the operation. So it works as a LIFO, that is, we have converted the FIFO principle into LIFO by using two queues. So let's move ahead and see the code for NQ operation. So first we have to, in this case as we are using the two queues, so we have to perform the NQ operation twice for Q1 and Q2 and again DQ operation twice for Q1 and Q2. So this is basically the NQ operation. So we have to follow the three steps for insertion. The first one is to declare a node, then to allocate dynamic memory and then set point of a node. So the struct node QU1 star NP1 is the declared node for the Q1 as NP1. Again, we have to give dynamic memory to it. So we have given it like NP1 equals to struct node QU1 malloc size of struct node QU1. So in this way, we have allocated dynamic memory to the NP1 or the first queue. Now we have to set the pointer of NP1. That is, as we are going to use linked list, so it will have two parts. The first one will be data part and the second one will be next part. So the NP1 of data 1 equals to A and the NP1 of next one equals to null, as the linked list is empty in the current situation. So we have to check the condition if F1 equals to null. If F1 is null means Q1 is empty. So new node will become F1 and R1 in this case. Again, R1 equals to NP1. That is, new node is NP1 and we have to make it as R1. Again, F1 equals to R1. That is, we have to make R1 as F1. And after completing this if condition, we have to go for the else condition. That is, F1 is not null means elements are there in the Q1. And if elements are present into the Q1, then we have to make R1 of next one equals to NP1. That is, make NP1 as R1 of next. And R1 equals to NP1. That is, make NP1 as R1. So this is basically the NQ operation for Q1. So this is the similar case for the Q2. Only the difference is that instead of NQ1, we have to make it as 2. And all the places at which we have used QU1, instead of that we have to use QU2. So this is the same code for the second queue, but we have to change from 1 to 2. So let's move forward towards the next point, that is the code for DQ operation. So again, int DQ1. Again, this will be for 2 queues and hence we have taken the queue of Q1. So we have to again check the condition if F1 equals to null. If condition true, then Q1 is empty. Or if it is false, and then if it is null, then we have to print that no elements are present into the queue. Then else, if the queue is not empty, then we have to make Q1 equals to F1. That is, we have to choose which node to be deleted. That is, F1 store it to Q1. First we have to check which node we want to delete and then we have to store it in Q1. So again, F1 equals to F1 of next one. That is, F1 will change to next node. Again, A equals to Q1 data of data 1. That is, node deleted will be Q1. So data part of Q1 is stored in A. And then we have to free the Q1, that is, we have to release memory. And at last we have to return A. It is return A where DQ1 function is called. So this is basically the DQ operation for the Q. This is for Q1. Again, the similar case will be for Q2. There also, instead of 1, we have to write 2. So let's move forward towards the last point, that is the main code of the program. So what we have to do, as I have said you earlier, as we are using 2 queues, we have to perform the DQ operation from the first queue and we have to perform the NQ operation on the second queue. And the last, and we have to perform the DQ operation on the first queue until we get the last element, and then we have to pop out the last element from that queue. So that will work like a last in first out principle, as like a stack. So in this case, without using a stack, we are implementing the stack by using 2 queues. So the main code will be, we have to check while F1 not equals to null or F2 not equals to null. That is, if F2 equals to null, then again condition is there, that is while F1 of next not equals to null. If that is the case, then we have to perform NQ operation on second queue and DQ operation on the first queue, as I have told you. And then we have to print the message as DQ1. That is, we will get the last element which is then present into the Q1. Else, again there is condition for the second q, that is if f2 of next to not equals to null, then nq1 and dq2. So in that case, we have to perform nq operation on the first queue, whereas dq operation on the second queue. And again we have to print the message, that is dq of 2. So here we will get the element which is the last element into that queue, and hence we will pop out that. So this work exactly the same as how stack works on the principle of last in first out, that is LIFO principle. So done with this code. Now we will see how this code works on a compiler. So let's see the code. So this is exactly the same program which I have explained in the PPT. So let's try to execute it. Yes, so we are getting the a message as enter the number of elements to be entered into stack. I will give it as 5, and they are asking about enter the element to be entered. So I will give elements as 23, 45, again 23, 7 and 9. So you can see guys here that the element which we have entered at last, that is 9, that element is popped first from this, and hence we have implemented the stack by using two queues. So the input was 5, 23, 45, 23, 7 and 9, but we are getting the output as 9, 7, 23, 45 and 23. So we have implemented the stack by using two queues. So this was all about today's session. Hope that you guys are now clear with the concept of how we can implement one stack by using two queues. So I will suggest you guys that first of all, you should try this on your own. Try to write it with pen and paper, and after that try it running the program by yourself. So if you get any of the doubt in that, then you can again refer to this video, or we are also providing some notes or the PDF file of this. So thank you guys for listening to the session. Thank you.